Okay, I thought about it while I was on the beach, and what I want to do today is put higher ranked types into the language, into the top-down segment. I kept saying that I wouldn't do it, but I want to do it. You know, even if it takes a while, it's not like we're going to get anything by finishing this project quickly. It's not like I'm, getting paid to do this. And even if I do this project, it isn't really a given that I'll make anything from it. So adding higher ranked types to language might prove useful to other people in the future as well. So let's just do it. I simply feel like it. It kind of irks me that the language just doesn't have it. I hate not being able to do that function that I did yesterday. And the way we're going to do it is really quite simple. I said that it will be a complicated feature to add, but to actually add it, we just need to enable it in the parser. And after that, we just have to add one thing to the language, and that would be, we're going to have a variable, and then we are going to prefix it with the $sign, and that is going to be a sign to the type inferencer, not to apply the type variables for it. Maybe we will make a demand that such variables be fully type inferred. But that's basically it. I guess... oh, did I not commit this? Now let's make a new branch. We'll call it higher ranked types. We'll also publish it. Now, I guess we'll start with the parser to... okay, so... okay, here's how we're going to do it. No, not infer, but we start with block parsing. And let's go into the root type. That's the parser for all types in the language. Where is the root type? Here, and we're going to simply add a parser to parse the foralls. Let's put a bookmark here, and then we're going to check out in other places how it's being parsed, especially GADTs, for example. Foralls. Here's the case for all. No, not that. Where is the union parser? Union. We did this in a previous video. Like we had a union parser, union clauses. Why is it not root type union? There's so many of these. And yeah, here we have the optional for all. Yes. Yeah, this takes a single type variable. Okay, let's see. the forall. And this returns what exactly? A list of type variables. Okay, I see. Okay. So let's put a bookmark here. Let's also put one here. Now we'll go to... Okay, this one we can remove. Okay, it seems like, you know, in the peak, it didn't put the bookmark where I wanted it, but it's not a big deal. I'm pretty much brain dead today. It's not that I went to bed late last night, but what happened is that I realized that I lost the campaign in XCOM because I let the alien... because I didn't build enough interceptors and air technology for the air game. So now what's happening in my XCOM campaign is that I'm slowly losing resources and I'm not renewing it because I lost all the... because my interceptors can no longer shoot down the UFOs and I've lost all my satellites. And I don't have the resources to build more interceptors or the weapons for them. So I basically lost the game at this point. It took me a while to realize it. I underestimated the aliens. Actually, I know that I was going in that direction, but my plan was to take alien bases. I think in the old Long War game, the alien bases gave a lot of resources, but in Long War Rebalance they're much easier and they basically don't give any resources at all. So I got my ass kicked that way. I was focusing too much on you know, upgrading my soldiers and barely at all on the airplanes. Leave it alone. It's actually pretty annoying that I don't have a chance to recover and have to pretty much restart the game. In the early game, I was pretty much you know, swimming in resources. I was getting a ton of credits every day, and I was getting, you know, alloys, iridium, meld, but all of a sudden that stopped coming in. Okay, this is set by, and that's not good. Okay, let's... We need this pipe too, and an optional forall. Okay, let's do it like that. Pipe 2. And okay, functions. And okay, what's happening here? Option fallback, relative forall. Okay, let's you know, let's just copy this. Yeah, I think this should be fine. And what this change will do is so that in every place that can parse a type, it will first try parsing a forall, and that will give us that will allow us to put foralls, you know, in annotations. And we need that for the higher rank types. Anyway, going back to XCOM, what this had an effect on me is that I became obsessed on thinking about how to improve my strategies. And you know, when I entered that kind of mental state, I was pretty awake. I went to bed at 1 AM, and I was pretty much awake for a very long time. I remember, you know, poking my head out and taking a look at the clock, and it was 5 a.m. So basically I was just thinking 4 hours straight and not sleeping. I only did that because I saw that there was light outside. Fuck. Well, at least I'll be able to sleep well today. You know, usually when I'm dead tired, I can still sleep. You know, from not sleeping well the previous day, I usually sleep well the next day. Because, you know, I'm too tired to give a shit about anything at that point. And that allows me to actually fall asleep. Okay, let's see. Yeah, we need to go into the infirm. And we need to start our work here. But more than just this, we also need to maybe add maybe we'll add a new node type to the language. Okay, let me think about this. Is top and down. Case for all. Okay, is the case. Wait, yeah, what I'm looking for are the prefix operators. So, okay, if you look, yeah, this is it. Unary prefix operators. This is going to be a, you know, a term expression. Let's use the dollar sign. And okay, what we have to do is yeah, this is going to simply parse a variable. Let me just think about what these parsers are doing. You can parse a variable value is top down, else. Oh yeah, I kind of forget that we even had this thing. Like, this is for splicing literals into foralls, I think. Route type, route term, route lit to type lit. Oh yeah. We pass a literal into this, and then it gets passed into a forall. It didn't see much use at all. So, you know, maybe we'll do a grave and then a dollar sign for this operator rather than you know a straight up dollar sign. Okay, so what we have to do is, I think, parse a variable. You know, we have the read var here. Just why do we have some? Just why do we have so many variables? Update semantic. This also bypasses the range. Okay, so we'll just read a variable. But that was the only thing that we needed to do. That would be great, but it isn't. So what I'm going to do is maybe extend this variable with a boolean that says, is this variable, how do we call it? Should the type variables be automatically applied to it? And I think this is going to be true by default. And the reason why I'm extending this instead of making a new node is so it breaks everything, and that will make the pre-pass passes a lot easier. The reason for that is I don't want to go. I don't want to have to make new logic in the pre-pass. There are a bunch of analysis, and it would be easy to get it wrong, I think. So it's better to just have the type errors guide me, so I fix all the errors, and this is going to be true everywhere. Except that operator case. And as we do this, the language kind of gains in complexity. It's unfortunate. Actually, let's go back. Let row v, and then and then we'll just do this. Row v. Row v. It's easier to get a better tool than a better brain. I really hate not being able to code something up. Programs should be written in the way that I want them to. Row v. Perfect. Now, this is the one place where x false. This is the only place where this will be false. I think that should take care of it in the parser. Uh, 2024 is an amazing year for Spiral development. I never thought I'd just come in and implement pretty much all of the features that are worth putting into the language. It's amazing. Okay, so now no, not the pre-pass. What we have to do is work on, I mean, okay, here is one place. And now we have to go into the type inferencer. And what we have to do here is pretty simple. We simply have to stop the type variables from being annotated. Sorry, I got interrupted. What was I going to do right now? Okay, here we are in the infer module. So this isn't affected by it. Oh, this thing. This fills in the forall cases, and yeah, it gets the. I wonder why it's not getting the. Whatever. Anyway, this kind of gets the type application arguments. I'm like excuse me, let me digress for a bit. The way this dictionary works, this type apply arguments, which is supposed to contain the arguments that need to be type applied, and it's referencing the string itself rather than the node. And I'm just wondering why that is, because I remember this string needing to be referenced by reference and not structurally in the dictionary. So I can't really recall why I decided to make it like that instead of having it reference the node instead. Okay, well, whatever. What this is supposed to do is very simple. It just takes the type application arguments and then puts a row apply and row type. It just puts in a bunch of type applications. This is where it's done. And there is some stuff here that the way the type application works is different depending on whether the type is a recursive term or not. And if I had to design Spiral again, I just require all recursive functions to have full annotations, so we don't have to mess with this shit. First I designed it, and then I realized that needing to type apply recursive variables, it requires some kind of a huge hack, and it was complicated. So I'm not really sure. First type apply arguments, and this is okay. Who knows what the hell this is? I don't want to bother with trying to understand it right now. I only have like a third of my brain working properly today anyway. So this is when the automatic type application is true. If it's false, then I guess it just return the node itself. So I'm kind of wondering why would this Why would this sometimes be false? I don't know. I mean, shouldn't it be a compiler error if it cannot fill in a type variable? Either way, it doesn't really matter. So what we'll do... Okay, let's go to the next case. And this is when this is true. Row v. This is the term. Type for all. What's this annotations dictionary? Wait, okay, here we have the default lit, and this is adding the current type, and what it needs to be, its principal type needs to be filled in. So what we are doing is adding the type to the annotations, so it can be filled in later. I mean, we're adding the node to the annotations dictionary, which will provide the type for the default literal, and the default literals in Spiral are like, you know, 0 and 0.5 or something like that, but they don't have I32 or F32. Those are regular literals, and the default literals are those that don't have a type specified in them, so they need to be annotated in the top-down segment. In the bottom-up segment, they simply get parsed as the default integers and floats, and get assigned values that way. So okay. Oh yeah. No, I mean, where is this getting added to the annotations dictionary here? I'm confused about this part, because we're adding the hovers here. We're also adding the type apply arguments, and why the hell do we need annotations for? I understand why we need them for default literals. Functions, for example, also need oh yeah, functions. Oh yeah, these are the annotations for the functions, because in Spiral you can have, you know, fx equals x, and this wouldn't be if we didn't put the annotations, then closure conversion wouldn't be possible. I see. Okay, so that's the reason. Okay, so let's do something. Is tvor applied, then else and this is doing forall substitution. What this does is takes in the forall in a function and replaces them with meta variables. Then it does some unification. Okay, so This definitely doesn't need annotations because foralls cannot have annotations. Okay, let's forget this thing. I don't think we should be substituting the foralls, so I'm not really... wait, what did I do? Yeah, I didn't mean to... Also, we shouldn't substitute the foralls. Okay, we want the core types, we don't want the type applications. As to where we are passing a function in type apply arguments, I think for recursive terms we needed to, infer the types for them like twice. So, because, first time they'd be meta variables, the other times they'd be, after the function has finished the typing parents, it would have concrete types. So I guess it needed to be done again. When I wrote this, it was long ago, and I forgot the exact logic. And my brain is too tired to mess with this right now. This is a list of type variables, and this is the body. Yeah, I can imagine. Oh no, wait. No. It isn't a list of type variables, but this should be a list of meta variables. In fact, yeah. It makes a new type variable. Then it substitutes for meta variables, and I'm kind of wondering what this L here is doing. These are the L. This is the meta variables. And these are the variables that need to be type applied. Oh, okay, I see. And this just reruns this function. Okay. So I mean, it's actually easier to do it like this than coming to do automatic type application. So let's just take a look at how foralls are being unified. Let's also put the bookmark here. We're going to unify GDT, and we are looking for the forall case. For type for all AB. It substitutes one type variable on the right side for the one on the left side inside the expression, and then does the unification. Yeah, that's smart. It will be a bit inefficient, but it's not like you'll be using higher ranked types all over the place. Yeah, I like this. Oh, this is fine. Now, oh yeah, I think that this is basically it. We just need to think about some things. First of all, I think the type annotations that have foralls should not have meta variables inside of them. They should be fully annotated. That's one restriction we'll want to put in. We'll do that later. For now, let's go over the prepass. And we don't need to consider, whether the type variables need to be applied here. And yeah, I think this is it. Let's just take a look at the type expression segment, and for all, maybe type for all. For fuck's sake, where is the T? No, not this, but raw T for all. I think this is the place that we need to do the check. Let me just search a bit more. Yeah, this is the only place where we need to actually do the check. And in body variable, we need to make sure that first we need to make sure that the type variable is actually being used inside the forall, and we also need to make sure that it doesn't have any meta variables, I think. I mean, how sure am I that we don't want any meta variables in a forall? We do want to make sure that the type variable is actually used, but why couldn't we have meta variables? I think we do have some, when type checking recursive functions, we do have and functions in general, we do have some checks to make sure that all the type variables are used inside the function itself. So we're going to look for that error message and trace back from it. But for now, I think we could just try building it. Let's see what happens. It should still work in without the checks, at least, as long as we don't compile it. Well, Okay, so let's go into the VS Code plugin, launch. Wait, this is in tutorial 1. This thing is type substitution. I mean, okay, let's make this test 26. I mean 97. I mean 97. We'll copy this, make it 98. Do higher ranked types work correctly. So we'll have inner main, and here we have inner, okay, f id forall t equals and then okay, here we have the x and then id x, and what we want is f something like id, and then we want some kind of value. Let's make it true. And we have the first issue in that it's not really parsing the forall at all. Maybe we need to put it like this. Okay, I have no idea. Let me just pause for a bit. Let's try to figure out what's wrong here. I'm not surprised that we got this error. I mean, it's indicating that it's not parsing a forall, but even though it should be. So what we're going to do is take a look at the type annotation case and go over it one by one. Let's see. Case. No. Okay. How are case in all? Not case for all. Maybe we need the statements. Just a second. Operators. Okay, here's the statements. Or let term root type annotation. Is top down false? Why the hell is false? Allow term. Just testing whether it's top down. Okay, let me. I'm really too fucking tired for this, but we need to figure it out. Like annotated body. When it's parsing spec inl, and then yeah, we parse a pattern. Okay, root pattern. Wait, it parses a pattern. It's parsing. I guess we should look into root pattern. God damn it! Now I lost track of NL or let. Root pattern pair. Pattern pair, pattern where. Root pattern rounds. Is there a path var or it's a root pattern type? But then, why is this not working? Like, oh, you know, I did something really stupid just now. I think I forgot to simply publish the stupid thing. 26th, and today is 27th. So yeah, I forgot to compile it. No wonder it's not parsing it. Okay, this is getting parsed. Suppose we did it like this. Yeah, it's also getting parsed, I think. ID is forall t. Yeah, not bad. And this ID is a forall variable. Nice. Wait, does this... is this importing? Yeah, it's importing the core package. I guess that's why we have the identity. Try to unify a type variable t with a meta var outside its scope. So for our AAA. This is going to take some work. Yeah, this isn't what I thought would happen. Wait, let me think about this. It's... yeah, this is for T, and this should get generalized. Let me think about this just for a bit. We have F. Okay, I'm going to cut a pause to really think about this. Right now, my thoughts are not flowing properly, and you know, maybe because I'm tired, it started to feel easy. It started to seem like implementing this would be easy, but it doesn't seem like this will be the case. my focus is not there. It's giving us a very strange thing here. This should be A. Yeah, at least it's definitely generalizing the ID here correctly. But if I do Q equals F, oh, what the hell? Yeah, so something weird is happening. Let's do this. Forall X. And if we do this, okay, so the first problem is that is trying to do something weird here. So yeah, going into the unification, it takes in a meta variable, and I think it encounters the forall var. It tries to unify a meta variable with a forall, and that's what we need to think about. Let me pause here. Doing this feature will take some effort. Okay, I just looked for the error message, and you know, this is where it occurs, and this is the only place where it just like, and this is the only place where it actually gets gets generated. And if you look at here, we have the tie exists, tie forall, tie null, and the tie forall is just dives into the body. It doesn't even consider anything else. And you know, when we didn't have higher rank types, this kind of behavior made sense, but now it doesn't. So we have to think about what we want to do with validating the unification in the presence of foralls. Yeah, it will try to. Yeah, it will check the scope and get an error. I mean, for the four variables that are inside the body of these, maybe it could, you know, ignore them. Would that work? And what do I have here? Let h equal hash set identity, and we're just going to add these to the hash set. V and then F A, and we'll also just remove it and remove V. But to be honest, we don't really need to do that. I mean, whatever. We'll just do it like this. Wait, what's the problem here? Var list, and this is a regular variable. Okay. I guess for the tag exists case, it will have to be a bit different. Ah, damn it. You know, after getting used to Visual Studio Code, trying to program in regular Visual Studio is so annoying because it requires multiple keys for the same for the thing that could be done with a single key press in VS Code. So oh wait, okay, so now okay, list there. Fun V. I mean, we can write this in points freestyle. Not bad. That's one change. Oh yeah, we also need to, you know, when H contains B equals false. And in fact, not here. If we do it here, it will make the pattern matching case inexhaustive. Nested divers. Oh yeah, so now let's give it a try. Oh, great. Now let's see what's going on here. Yeah, it just returns the original type. Perfect. Now let's pass in true. And we're getting some kind of error. Oh wait. Yeah, come to think of it, this. Yeah, this forall also needs to be applied. If we just do like this, will get a unification failure because it cannot apply the forall with a term. Okay, so this works. Now suppose we try passing in the identity function like this. Got forall ttt and expected some function. So suppose we do it like this. Yeah, now it actually unifies correctly. And it returns a bool at the end. Yeah, perfect. Yeah, I really like this. Yeah, based on this, we can conclude that the higher ranked types in fact work in Spiral now. But of course, this isn't the end of it. Let me talk about the bottom-up segment. The bottom-up segment doesn't actually support the foralls, and I don't think we'll even be able to evaluate the forall types. What would be great if we could it's probably not the best idea to restrict the foralls from appearing in the bottom-up segment at all. But yeah, now they'll also be appearing in the type case. We'll have to restrict them from being matched there. Okay, let me show you some of the problems. Let me just lower the table. Oh no, I can't see myself. Okay, let's put in a bookmark here and let's take a look at the type case. And it's the unification here. And the existential. Yeah, we cannot unify with an existential, and the same will have to hold for the foralls. Maybe we'll add something like y forall. Simply for the cases where it doesn't really remove the pattern annotations. But at least the okay, to do. Let's just take a look at roughly forall. We don't even have the case for them. We have the E forall. Okay, where is the? Okay, I think the type elevation is at the top. Okay, here we have the T exists, T forall, T arrow, T join point. So here we have the T forall. Private level foralls are not allowed in the partial evaluation pass. Yeah. So do you want to leave it like this, or do you want to do something smarter? Okay, let me restrict the foralls from appearing in the Bottom-up pass. I mean, in type case, in the bottom-up pass. Block parsing, type case. It actually parses the type case right here. Like, I'm not really doing anything special to parse the type case. The only thing type cases can have in the bottom-up segment that the regular annotations cannot are meta variables. You know, by that I mean variable prefix with a lambda and wildcards like this. So what do we want to do with these foralls? Let's pause here. I'm so tired. I just had to take a lie down. As I said, today I'm very tired. I've been thinking about what we need to do and how to restrict the foralls in the type case in particular. But it turns out that has already been done. Good work, past me. I really did a good job with this. Now I don't have to think about how to take care of this. Now, instead of having this here, we're going to make this the same as this. I mean, and we might as well disallow the wildcards while we're at it. For rowdy for all. And okay, so let's add that here. I mean, do I have to do it here? I mean, we do if we want to disallow the wildcards. But if we did it at the other level, we could. It would be easier to. You know, we could write it as we did here instead of having to put it. Instead of having to put in a parenthesis. But maybe putting a parenthesis isn't so bad. I don't think the foralls in are going to be used that much in here. You know what? I don't care about this. Let's have it stay where it was. What the hell? We'll just move it up here if it starts causing trouble. So this is good enough for the parser. No. What do you think? I mean, I really would like to also have the existential be at the top level. To do all this. Okay, so we have this like so, and it's restricted in the type case. So I don't think the reason why we in the partial evaluator why we added this why exists type is so we can have existentials in nominals. And now we want that same capability as well. We do want to be able to write higher ranked functions in union types and nominals. I mean, why the hell do they even do this here? Like, I'm probably doing a lot of stuff in the prepass for this T4all type, but it's completely irrelevant. And what we'll do is y for all. Yeah, perfect. Maybe we'll just get rid of the... Okay, we cannot get rid of the T for all. I mean, why can't we? The arrow of... Okay, the type functions, that's a completely different thing from the for all. Okay, what I feel like doing is getting rid of this T for all case. Like, we don't need it. We'll treat it the same way as existentials. The arrow, okay, that's another thing entirely. And then now let's go into the prepass, and we're going to make some changes. Wait, this T for all. So. Oh yeah, the reason why we added to begin with is because of this bullshit in for the GADTs for the GADT constructors. That's when we added it. But you know, I really actually regret doing this here. If I had to do spiral again, I just do these constructors during the parsing stage and be done with it. Instead, I'm messing with the internal representation directly here. It's nonsense. Okay, so I guess we'll bring it back. Okay, thankfully it was still in the undo buffer. Now we have this. Now what else do we have to do here? I guess we'll just treat it the same way as we treat existentials. Y for all. We'll duplicate this for all. For all. error list. I think we actually need to publish it once to get all the warnings. Oh, really? There aren't any warnings. That's surprising. Let me just save this. And since there aren't any warnings, let's check out the code generators. We have 3 of them now. Why exists? Foralls are not supported at runtime. They are a compile time feature only. We'll just add this in the other places. Why exists? Why for all? This is the CUDA. Okay, here's the CUDA code generator. We also have the Python one. Why exists? For us, not supposed to at runtime, they are compile time feature only. Yes, this is the behavior that we want. Maybe also we should check out the application in the partial evaluator. Apply, I think. D for all, cannot apply a D for all with a term. Where are you applying it? Let me put in a bookmark here, and then we'll do a search. E for all, where is it getting applied? Cannot record a for all into a type. Yes, you can. Wait, not this. Wait, we're not converting stuff into a type here. Actually, we are. Okay, so how do... I guess we'll convert it into a type variable. What about the existential? Push up bin exists. Whatever. What's this B thing here? That's the data. And what do we do with the data here? I mean, this thing has a body, it has a data array, it has a type array. Oh my god. I mean, do we need a din operation on this? I don't think we do. Like, well, this should be an error. Like, cannot din forall. Cannot din hash set. Yeah, we can in fact convert them the foralls to a type, but this shit. Yeah, I don't think we need to convert the existentials, at runtime. This should pretty much always be an error, I think. I mean, we'll figure it out when we actually try it. I think we just did this, but we never really tested whether it's necessary, even for existentials. Not bad. Cannot convention that is not annotated into our runtime variable. Yeah, not bad. We'll go with this. I'm pretty sure that we are not dinning existentials anywhere, and the same will go for the foralls. Now, yeah, let's take a look at where the foralls are used elsewhere. Type apply. In type apply, that's where that is where it's getting applied. What about the B thing? B is tie. B is already evaluated by the time it gets here. E-nominal type up. E-type apply. Okay, so here it is. Okay, so let's press Shift Enter to go back to the previous. I mean, a few times to get back here. What I have to do is just do an error. dv l y forall got a forall cannot apply a runtime forall during the partial evaluation stage. Oh yeah, this is good. And that's one of the errors that I wanted to put in. And Okay, when it comes to the code generators, foralls. Yeah, okay, here it tries to generate a type for the forall, but it can't because it's, opaque. We need something like, even if the partial evaluator did support runtime, existentials, and the foralls, we need something like a dynamic backend in order to be actually able to support them at a runtime. The C backend one wouldn't be good enough. Or rather, we need to compile to an uniform representation, much like the dynamic languages do, even in C, and that's beyond what I had in mind for Spiral. The foralls and existentials are just for compile time metaprogramming purposes. Let's close this, close this, close this. Oh yeah, this is... Let's also do an error message here. And it's the same thing that we had earlier. L Y forall. Cannot apply a runtime forall with a term. And yeah, we'll have the message be like this. Foralls have to be known at the compile time and applied with a type. Oh yeah, not bad. I love this. I mean, this A isn't used anywhere. Okay, I wanted to touch this. Let's not touch this. And yeah, I think this is good. Now what we have are high ranked types in the language. It's not that great. I thought it would take like 2 weeks, but it took like 2 days. Of course, we still haven't tested them out, and that will have to come in tomorrow. It's amazing what you can do once you set your mind to it, or at least a little. I only really, I need to stop saying but I also need to stop saying really. I only gained the desire to actually put them in once I saw a concrete need, even though it was really, even though it was really niche. But after we fulfill that, after we implement that function that we couldn't yesterday, we should be able to, once we gain that capability, we'll find other uses for higher ranked types. Who knows? And right now I'm thinking about Haskell, and Haskell has something that's called impredicative polymorphism. Really? They aren't... I thought that they were rank-n types. I was going to say that Haskell has higher ranked types, but now it's kind of making a distinction between impredicative polymorphism and rank n types. Just AA, maybe forall AA. Lookup table of strings to polymorphic functions. Okay, this is a list of that takes in a type A. So, you know, I was expecting to find something like the identity function that I wrote. I haven't really programmed in Haskell since 2019, when or maybe even earlier, when I studied functional programming. And again, it showed me a bunch of interesting ideas. It says that it was unreliable in the old versions. It was like that when I looked into these features. I'm guessing they got it to work well now. Forall SST SA. I mean, what's the difference between foralls under type constructors? Not just under arrows. Oh yeah, I hadn't thought about that at all. Like, so now that we have the okay, let's just build it. So I'm going to do some. I'm going to type out some things. I should really just ask Bing what the difference between impredicative and rank n polymorphism is, but I'm guessing the answer is that you can impredicative polymorphism allows foralls to be in like this in type constructors. Visible type applications. Oh yeah, that Haskell has a bunch of. I mean, of course, you can only really instance declaration with a nominal type, but the nominal type could have a forall in it. Oh really? So yeah, it had a hack for the reverse pipe operator. Haskell uses a dollar sign for what is this particular operator in Spiral. Okay, I cannot really understand exactly. I mean, I can't understand for sure what the. Yeah, this is also ranking type, ranking. This is like, you know, you look at the Haskell and it's a extreme autism. Oh, I didn't know Haskell had an existential. Like, what the hell is this? I didn't know it. Oh wait, this is pseudocode. There's no way this is real code. Let's just ask Bing real quickly what's the difference between Rankian polymorphism and impredicative polymorphism in Haskell. What is the difference between Rankian polymorphism and impredicative polymorphism? I'm pretty sure it should give me a Haskell example. Even within type constructors. Okay, I have no idea what the full implications of this are in the context of Haskell, but I'm pretty sure that what we have now is impredicative polymorphism, and I don't think this will be hard to do type inference for. But one interesting facet of it is that if you have something like ID x, okay, let me just write it out, from t x t, and if this is something like a forall, the type applications won't be applied automatically, but you could have guessed that's what the behavior of this should be anyway, so it's fine. Maybe I'm being a bit ignorant, and maybe I don't understand the true difficulties of type inference with impredicative polymorphism, but it doesn't seem that much difficult to me. Well, one difference compared to Haskell is that we don't have visible type applications. So if we have something like if we have some function, I may need to partially type apply it. We could have a function q which has an for all a, b, c, and I don't feel like writing out the whole thing. And then we have something like v, and if we wanted to partially apply some of these for alls, even if in something like the identity, we could just do for all a, b, I mean bc, and then just use q with some kind of type annotation or something like that. Okay, I'm going to go have lunch, and we'll actually test this out tomorrow. See you later. Let's finally do some programming. A new dev is here, and we'll test out higher ranked types. Let's get rid of the packages in this test, so it's not importing anything from the outside. And now let's just try spiral build file. Is it crashing? Oh yes, it is. What's going on? Oh, these cases should not appear in fill. Okay. Right. It's in the info module. Yeah, what exactly should I do here? Type forall, maybe. Then I think we need to recursively call it and be. Oh, wait. Row T for all. Just range. Okay, air and then a name. It needs a type var. But here we have only a string. Okay, what the hell is this type var? HOR. Oh, this is annoying. These are the constraints for a type variable. And this is the kind. Constraints, kind. Okay, do we have anything to actually convert that var to HOR? I mean, I vaguely remember. Well, maybe I tried it once, but I'm not sure whether I created a function to do that kind of conversion. And I wish it would be better if I didn't do that twice. Or type var. Oh yeah, we cannot forget to do. We cannot forget to check that the type var is used in the body var. So we'll leave that in. Wait, to do. We did it. Okay. Okay. Let's do let var to HOR. And okay, now let's also pass the range. Now on the left side we have the range. Then var string raw kind expression. X name X kind. We need to do a conversion function for this. Now They really not have the conversion function to convert kinds. I mean, to convert the type, the top-down kinds to raw ones. I think I do have at least that thing. So let's see. Kind. I really don't. Raw kind fun. They only appear on the left side in the patch matching cases. Never mind. I guess we're simply just going to have to do. I mean, convert everything var to HOR, and then now let's kind to raw kind. Kind. Wait, what's it called again? Oh yeah, TT. Raw kind. Match X with visit TT. And this will be what kind type kind fun. Okay, let's start with this and then let's pick at this and then oh yeah, it has a kind type. Okay, kind type and then what? Raw kind star AB. Let's make this recursive. I mean, the kinds don't matter at all in the bottom up segment. They aren't checked there. They aren't checked anywhere there. So it's not really important how we do this. Kind to wrong kind A, kind to raw kind B. Oh, yeah, we need raw kind fun kind metar. Yeah, that's what I said, what I did, what I just did a little bit earlier. We're just going to convert the meta variables to raw kind star and be done with it. Great. It seems like the kinds don't have ranges. I like it. Kind, raw kind. Okay, the H var. I think we need not that, but type var. Let var to type var Rx. And this is, yeah, now you have to go over the list of constraints and put them in, but you know, it doesn't matter. In the bottom up segment, the constraints aren't checked anywhere, so we'll just put an empty list. You know, I could have sworn that we were converting kinds to raw kinds somewhere. Maybe, maybe maybe what I'm thinking of is in the other direction. So that's probably the case. So I'm mistaken. Like we don't even need to be converting their kind to raw kind. We can just also put in a star, but whatever. I don't want to bother with that. Okay, that's taken care of. Now we can just use var to type var. Array. Perfect. Let's try publishing this. As usual, this publish button is just to publish it in the compiler folder. It doesn't actually push it to VS Code Marketplace. Yeah, last night I went to bed a bit earlier and I slept well, so I have the energy to do this right now. Spiral build file. Is anything getting built? Yes, it is. If we go at the bottom, it just returns true. So yeah, it works. If you put in false, no, it's returning false. Perfect. Right, how did I open PowerShell? Okay. So this works. It seems the what? The higher Oh, okay, so added. This is 28. Added higher ranked types to the language. Okay, first of all, now that we've come this far, let's check out whether what we had earlier still compiles. Here we have the layers. Like, can we still actually... Okay, let's go into the... No, wait, name list before the games. Yeah, I just want to... Okay, let's try... Like, reduce... Damn it, we cannot even run it because the machine learning library is in a broken state. We're going to have to commit here and go back to one of the earlier commits. I need to just... Okay, so let's see. Okay, which one do we pick? I have no idea when it was working. Okay, let's try this. I don't think this is it, but we've checked out this commit. Okay, so will this thing compile? Spiral build file. File layers. File layers cannot be found in the project. Oh yeah. Let's just restart this. Maybe because we changed the... Because we went to an earlier branch, so suddenly it... Wait, did I actually start the library without the extension? That could also be the case. What I wanted to say is that because we switched the GitHub branches, so suddenly the language server didn't have time to update itself. You know, it still has very poor support for Git, the language server itself. I mean, okay, so let's try build file. Whatever. Well, we're going to have to go even earlier. Done with the test. Okay, which test was that? I have no idea. Let's go even further back. Check out the commit. ML. Okay, hopefully this is a working version. What I want to test is whether simply compiling some of the tests in the layers module still works. Build. And here we have the layer spy. We're just doing a little check whether what we had before still works. And it looks like it does. Yeah, this is the test before we implemented the blocked, the masked softmax. And if you go into game model M, is anything happening here? Oh yeah, here we don't have a test. Do we have anything in here? Well, let's give it a try. Oh yeah, not bad. Okay, that's about as far as I want to do testing. It's good enough. Let's go back to the main branch. Check out. How do we go back to the head? Okay, now we should be pointing back to the latest commit. And we're going to make this function that we did a few, like, I think 2 days ago. But we couldn't because we didn't have the higher ranked types. So, okay, let's go into the primitives. Primitives. Where are the primitives? Okay. Now nominal compound. I think I think comp is a function in, yeah, it's a function in core base. So sin pair. Now how did it go again? We have a singleton that's just, I think, t. If we go pair, that's a GT, then A. B. Oh yeah, com A star B. Oh yeah, it also needs to be a recursive union. And this key needs to be for A, B. Not bad. Okay, so we have this com type. Now we'll do what? Yeah, map com. X. Yeah, we had this kind of function forall f g t g t actually it should be ft to gt and gt, and we had a forall here, forall t gt. Yeah, it needs to be, it needs to be in the type, not on the left side. And now we have this, and this f needs to be higher kinded. You know, it's pretty amazing. I only did some, dependently typed programming in Coq and Agda back in 2019, and then I didn't get much use from it. But now it's really showing its value. I can understand this type level stuff without any special effort. In case you're wondering, what I did is go through the software foundations book. And this thing has a bunch of exercises that you can do in Coq. It's actually pretty large. Going through all of this took me, the first two volumes, going through the first two volumes took me 2 months. It's actually pretty difficult, especially if you don't know any math, like I didn't. And it's actually pretty awkward. As I said, Cookie is the kind of program where you write assembly to generate code in a functional programming language. So it's actually, if you're going to start with dependently typed programming, it's a lot easier to do not what I did, but to do the version of this book in Agda, Software Foundations in Agda. This book isn't really as large as the Coq one, but it's a lot shorter. But you can write it in Agda directly. So you're actually doing the mathematical proofs in a functional programming language directly instead of going through a very awkward assembly layer. So doing this would be a lot easier. Oh yeah, I also mentioned the tag that is very elegant. So if you can see this natural number, let me zoom it in. It uses Unicode for pretty much everything. This natural number, you'd actually type it out in code like this fancy N. And this arrow, you also type it out, a special Unicode character. So yeah, I do recommend if you're interested in independently typed programming to go through the Agda book. I also went through the Little Typer book. Little. Yeah, I got this thing. It has a special language that's implemented in Racket, and you can go through it. I kind of enjoyed the experience of going through this book. Of course, this was in 2019. Maybe some other educational material came out since then that I don't know about. I mean, I haven't really been looking in what's going on. I actually tried, I tried going through the cookbook in maybe before I started work on Spiral, maybe in 2016, and I couldn't go very far at all. But in 2019, I had leveled up and I could go through it. And so I did become a better mathematician just by doing this kind of programming in Spiral. So they aren't really close to each other. Okay, so now we have to also input the f of t, and just do a function. Wait, should this be done like this, or should this be ft? Okay, let's do this like com. Let's go sin x f of x. This is f of t. gt, what the hell? I mean, I'm expecting this to be. Oh yeah, I understand. We need to return a sin. Yeah, perfect. Now this works. As you can see, the function gets generalized as being f of t to g to t. And then we have the pair case. Pair AB. And this is pair map com fa map com fb. And Why is this error happening? Let me think. Com G to T. Wait, maybe like cannot it split when we have f of t, but g of r. Oh damn! I didn't really expect this. Yeah, it cannot destructure this f of t type into pairs. It's an invalid construction. Okay, so I guess what we can do is this requires a higher kind. And yeah, you also need to put it in the forall. Oh, not bad. Now we have this f of t g of t, that should be fine. And this will be f of t g of t. Now, as you can see, it's destructuring it properly. And we have the pair. Yeah, it needs to be recursive. I forgot about that. And what problem is it having now? COM-TA. I'm confused. Why is this happening? Okay, let's try factoring this out. It will be COM-TA. I mean, but cannot it just infer what should go in here based on the type of pair? TB com G TB TC. Okay, I need to pause this so I can really think about this. This type error is confusing for me. Oh, I figured it out. I made a silly mistake. Comp FA, comp FB, I mean compound. And now the error goes away. Okay, this is interesting, but why did it give me a type error when I did this? Or yeah, I get it, because the type of this isn't T, but this TV instead. The type inferencer is right. So okay, now Great. This function that we couldn't implement 2 days ago, now that we have higher ranked types, we can. I'm going to change this from the dollar sign to something that's a bit easier. Let me think. Where is the parser? I mean, from the gray dollar, we just leave it as a dollar. No. Let's be consistent. We'll leave it as a gray dollar. It's fine, even though it's a bit longer to type out. And okay, so what we need is to actually test some other functions. Let's see. What I want to do is, check out what happens if the type variable in the forall isn't used in its body. So here we have the t, but let's assume we have something like this. Oh wait, let's put in an h here. The type variable h is used in the function's type signature. Yeah, that's pretty good. What if we had something like yeah, it won't be checking this, but now we should. Okay, let's go back into the info, and we'll check out this to do. Now, where is that error message coming from? I'll just copy paste it. Is unused in the function's type signature. Unused type variable. Okay, so we have a bunch of these asserts foralls used. Yeah, this is pretty great. This is exactly the function that we want, but we do want to use it in the right place. Let me pause just for a bit. Okay, what I wanted to do was check out. Okay, sorry, I had to go away for a bit. Now I'm back, and before we mess with the foralls, let's do one more thing here. I want to go through the old commit, so close but so far away. And what I implemented. I thought maybe we'd be able to find the old function. God damn it. I guess I removed it. I didn't commit it. It's very unfortunate. I do have it in the video recording, but who's going to go through that right now? Never mind. Let's just deal with the foralls. So They could only come up in in functions and the type annotations. No. I mean, that's on the term level, but they could also come in type signatures. Okay, so we have to use this in like two more places. In nominals, unions, regular types at the highest level, and type signatures. Okay, let's go one by one. We'll just test out all the cases that I can think of. Now, let's figure out. Let's put a bookmark here. And we'll check out where this is used. In GAT constructors, okay, in type union, this being asserted. It's used in generalize, okay, that's fine. Bundle prototype. Oh yeah, I forgot about the prototypes. We're using that here, but we aren't using that in the nominal. I mean, in regular nominals and types. So okay, we also want to use that in type annotations. Now, let's do rav and not. This is type checking this. No, it's not. It's filling. Assert foralls used. B. And oh yeah, we kept passing the errors. Enter errors. Ah, damn it. Can't it compile it a bit faster? And in the past it would try a few times before aborting. This time it fails right away. Here we have a type annotation, and we're testing whether this int is being used in the body, and we aren't getting any errors. So that's a bust. Having to put in the assert foralls used everywhere manually is such a chore. We'd be better off just implementing them in Thai. Okay, we are going to use the solution that I'm going to do here because it's very awkward, but I mean, we aren't going to do the solution that I'm going to do here because it will be a polynomial time solution, but I'm going to put it in here just so I can check out what's happening. Error. Errors, error, and then S. Let's check it out. Oh wow, this is fucking ridiculous. What the hell? Why aren't you getting an error here either? I mean, okay, this is very confusing. Like, for all. Yeah, this is very confusing. Yeah, now it's giving us an error. Excuse me. Okay, I think I understand why this error is happening. It's because we aren't visiting the meta variable. I think in this function we are kind of assuming that all the meta variables have been substituted. So what you need to do is hit the visit t function. Match visit. We can skip this. Now this metavar case will make sense. Let's try publishing it again. Oh, perfect. Now it's finally giving us an error. And even if we put it like here, now it works. The function doesn't explicitly need to have foralls in order to work. I mean, the only question is how exactly do we make this not be polynomial time? And I'm getting an idea. No, it's not a good idea. I mean, whatever. I guess we'll have to go to what we were doing before. Assert for used. Let's go into raw anot. But yeah, it really is awkward to have to keep using that pretty much everywhere. Okay, we're going to do a redesign of tie. Oh, no, the idea that I had wouldn't work. Okay, let me pause here so I can think about this issue. It's more complicated than it seems at first glance. We want to assert that every type has properly formed foralls, but we don't necessarily want to use a polynomial time algorithm to do that kind of type checking. And we don't necessarily want to check every single invocation of tie. That's a problem. Maybe we could make something like tie init. Tie it. Okay, why don't we in fact try that? This will break everything. And tie init. To arguably, what about the functions that call tie quote? Oh, this is only called in one place. Oh, that's fine. And tie init. This one just called tie in SX, and it will also assert foralls used. And now I have to make sure that the functions outside that are calling tie are actually calling the right thing. Tie init. Well, let's see. For fuck's sake. What the hell did I do? Init. Yeah, it's much smarter to do this than to have to manually. Oh yeah, while we are at it, we could also ensure that maybe the type variables in existentials are also being used in its body. That's a good thing. Wait, errors are okay. Range of the expression. We should assert foralls used, and we should also be checking the existentials. HR, ignore. Oh yeah, I do think this is in fact checking the existentials, so it's fine. Let's get back to going over the errors. This raw macro, oh yeah, this also needs tie init. Yeah, imagine having to try to figure out where to put those assert foralls manually. That would be incredibly error prone. It's easier to break the program first. Routing union. Multiply. Bundle nominal recursive. Routing union. Pattern annotation, yeah, this needs tie init. Bundle prototype, this needs tie init. Bundle type, now it will be checking the foralls here. Oh, perfect. Now we can just bring back what we had before. Perfect. And they doing this kind of change like this is much easier than trying to remember and do it manually. I'm really glad that I'm not using dynamically typed language right now. The only thing I'd like to do is get rid of this assert for us used in other places, like we have it here, and I don't think we really need that. We really need that anymore. Init body. It's checking it out in the body itself. The expression. Oh yeah, but yeah, at this point it doesn't actually have the forall variables yet. Oh, that's a problem. But if you think about the nominals, you know, we can something like for fuck's sake, let me just run this. You can have something like a nominal foo t, and then like this. And we don't really want to have to use the type variable inside the body. So yeah, this kind of behavior is actually fine. But what about if we had something like type footy? And okay, and suppose we do foo int I suppose we did something like this. Oh, it still works. You know, whatever. It doesn't matter. We could add this check to the type statement, but it wouldn't really be gaining us anything. It was done like this before, and I'll respect the design decisions of my old self. And the prototype definitely does need the assertion. But as for the rest, it's fine. Whatever. And suppose I add h here. Oops. Suppose I add h here. Oh, why the hell is this thing? The type of h is unused in the function's type signature. For some reason, the value h is unused in function's type signature. Yeah, it does happen in two different places. Oh yeah, the error gets added twice in this place. Wait, I mean, when it's doing type checking here, oh, I see. So showing this error in different places. Around h, here's just once, here is twice, here it shows up like 3 times. Okay, that could use some work. Wait, am I maybe triggering us? I mean, here you have the type for all. I mean, I can get the sense that it's getting called many more times than it should. Drop the like how many times is it going to add this error? It should add it like only once. Tie init row on it, row exists, row macro, recursive block. But annotation, I mean, you should just call it once. Bundle nominal recursive. Okay, I'm going to pause here so I can figure out why it's putting the type error so many fucking times in this place. I'll be right back. I figured something out. We're passing this resize array into here, but it could have a count more than 0. So this isn't good. Instead of passing the array, we should be returning it. What? Oh, not bad. Oh no. Like, do we really need this right here? Type union, play is the union type. Okay, here we have the type union. GDT is valid. Outside foralls. I mean, I don't think we really need this anymore. But when it comes to ranges, yeah, the ranges for this, we want what the hell is the body here? Route union. Yeah, we do want the proper ranges when asserting that the foralls are used. Validate nominal, body, V. And okay, for this in particular, maybe it would be better not to. Okay. Okay, this is an interesting case, and what we're going to do. Like, okay, shouldn't it be returning? Oh yeah, I actually didn't do that. We need to return the errors, add, and then now it's complaining. Add range. We'll have to put this in a bunch of places. Assert foralls used. And when it comes to that union type, we're going to pass at the top level, instead of, I mean, we're going to do it twice, but for the initial pass, we're just going to give the name of the union as the range. We don't want the unused forall variables to be over the entire union. Not bad. Now let's figure out the top level union case. Okay, this is bundle prototype, bundle nominal recursive, bundle nominal recursive L. So this is one thing, and tie init should be called in here somewhere. Yeah, here. Sorry, I got interrupted. Now, where are we? Yeah, here the tie init is called. And this is where the initial think on the entire body will get called on the body of the union. And I don't like it if okay, let's go into tie init and we'll go into tie union. Route union. Yeah, here's the range. Route exists. Oh yeah, we don't have the name here. Damn it. Okay, we're going to have to call this tie directly, and then we're going to assert the foralls, but we won't do that in the same way. In fact, yeah, let's not even call tie init directly in the recursive nominal thing. Yeah, I mean, we shouldn't do it if it's a union. Okay, I understand. Assert raw foralls used, tie union. This type is never supposed to show up raw anyway, so you can just do it like this. Even this time module, let's just put it here. Like, we don't really necessarily need to check every single thing. Yeah, we're going to take advantage of the fact that this isn't like this isn't a spiral from 2018, and we don't have unwrapped union types. They'll be always wrapped in a nominal. Let's do this. This is one type error. This is one type error. Yeah, perfect. This is exactly what I wanted. It no longer has a bunch of nested type errors. To that being said, I'm still a bit confused why it happened multiple times. I mean, yeah, it could happen due to previous type errors, but okay, I mean, just how many times is that function getting called? Maybe I'm simply overthinking it. Maybe I'm just confused why it would happen the way it did. Maybe I should think about it a bit more. Assert foralls used. If Wait, what did I do? If 0 less than... Wait, I did something pretty silly. I mean, the change that I did here shouldn't have fixed the problem of multiple type errors appearing here. Oh, okay, let's backtrack after all. I'm going to... I thought the errors are getting added based on the existing count of errors in the array, but that isn't the case. They're getting added based on the how many variables are left in this hash set. I should be able to understand how to fix this error clearly. No, let's see. Okay, and now it's working properly, as you can see. I mean, the errors are showing up properly. Maybe it had something to do with disabling the union type. It's very weird. Anyway, I'm not going to bother with this any further. No, I mean it cannot possibly be due to me changing the way the union types are getting printed. I mean, we could go back and save. We don't want to put in save hash2 because that will reference the previous issue. I mean, on the GitHub repo. No, okay, let's undo all this. You know, I'm kind of wasting your time right now, so I'm going to pause and figure out. Okay, I've done some testing, and I cannot replicate that erroneous I mean, those duplicate error messages showing up anymore. I don't know why that happened. I guess I need to go back through the video to figure it out exactly, but it doesn't matter that much, and it's not showing up, so whatever. Maybe it's kind of some weird VS Code thing. Assert foralls used. Okay, now here we have this entire union. We have the validate nominal. Tie in it. Around the union. Yeah, this doesn't do any extra checking. Yeah, I'm just wait, where is the tie union? Yeah, they didn't have remove this. What the hell did they do? Like, this is so annoying. Yeah, we had the tie union here. Okay, let's just put it back where it should be again. Now the validate union shouldn't be giving us trouble, and we're done basically with this. We'll just test out whether whether the forall validation works properly in union types. Suppose we had something like forall x, the variable x. Yeah. This is fine. I mean, no, not this, but for fuck's sake. Is a news and functions type signature. Okay. Union. Yeah, perfect. Yeah, unions are a bit special, but what about suppose we had ranked type forall t, I mean forall q. Oh, yeah, we also should be testing for shadowing of forall variables. That's a bit awkward. Now down. We also need to test whether the forall variables are used in the body. Okay, so let's why is the license open? Error source for rows. Range of expression body. Not the union. But wait, why is it? What is it returning here? Bool unerotic expression. Like even so, why is this giving the right side of the? Yeah, can't we get the range of the entire body? How is it getting the range? Oh, yeah, I'm so confused here. Like, why is this? I mean, I get what the body is, but shouldn't it be the entire thing rather than just the right side of the arrow? That's what I'm confused about. Okay, let me pause here. We pretty much implemented the fucking rank types, and I'm just fiddling with this edge case. It's amazing. Oh wait, I get it. This is getting the range of gedit constructor. So that's... there's also gedit body and the gedit constructor. Alright, okay. For fuck's sake, I didn't see that it was using a special range function. I thought this was just range of the expression. I mean, what about the regular union types? What about the regular union types? We still need to assert that the foralls are used there. If is stack, assert gedit is valid. We this is like if not is gedit. Start nominal is not recursive. Okay, else let's do it like this. If stack where's the range? Range of the expression, range of also, I think yeah, the regular nominals will get checked. No problem. Now we'll make sure that this works. Yeah, perfect. This is exactly the kind of error that we want. What about nominal? Yeah, they are getting checked. The only thing that really bothers me is the shadowing of forall variables. We need to make sure that the forall variables aren't being shadowed. I mean, is it really a problem when the foralls are shadowed like this? I mean, they can only be applied. Yeah, I don't think it's really. Yeah, I don't think the shadowing of foralls is really a problem inside the high ranked types, though I could be wrong. I mean, the reason why we disallow the showing of foralls in the top-down segment is so it can fill them in properly. If we have something like fuck's sake, QA and then forall T X T and then forall T X and then we call as D And yeah, I have when I demonstrated this once in the past, I did the equality example equals forall I don't know if we suppose we call equal xy. Now it won't really know which variable to fill in. I think like if we didn't disable the forall variable shadowing, I mean, they still wouldn't be the same type of variable. Okay, you know, the logic of this made sense to me in the past, but since I cannot exactly remember the exact problem, that's kind of a sign that the logic wasn't very sound. The truth and you know, generally the things that make sense and are easy to understand, you remember them, but the things that are confusing and you only understand them at the moment but forget them later, those are the things that tend to not be right. So in general, if you write a piece of code and you remember what it does a few months later, then that's pretty good code. But if you forget what it does like very very quickly, then that's a sign that it's pretty bad piece of programming. So maybe the top-down shadowing is unnecessary. Like actually, I remember. Yeah, I remember exactly now. It's in fact not unnecessary. Suppose we do equals xx, and we are ignoring the y here completely. What it would do is, suppose we didn't have forall shadowing, what it would do is type apply the variable t to this equal function, and that would end up applying the wrong forall variable, not this t, but this one here. And ignore this equal to ASD for the time being. And now you can kind of see what's really the issue. This is why the shadowing of foralls is necessary, but would the same thing be necessary when we have foralls in higher ranked types? I'm not sure that would be the case. I mean, in automatic type application, you would just grab the type variable from the environment and apply it. And yeah, okay, we're going to factor this example out into a test. Yeah, simply so I can remember it in the future. perfect. Now let's stop here. I need to go have a breakfast, and when we get back, I think I'm going to... What I'm going to do is release a new version of Spiral. We also have to write out some examples in the documentation. Oh yeah, before we do that, we should also try refactoring the primitives module. So the code that we have written out can actually be used. But right now the whole module is very broken to begin with, so we cannot do that testing just yet. Whatever, we'll release the new version of the language and then we'll test out this particular feature later. It doesn't matter too much. Like, there are going to be bugs either way, who knows, something that I completely didn't anticipate. Are you going to be fixing them, just like in the case of GADTs? Let's stop here for an hour or two. Let's resume. We're going to test out the new features by implementing that function. I mean, we already did that, and what we're going to do is redesign the library so it uses this map.com. Let's see. We're going to get rid of the raw pair cases and instead replace it with the com type. So how do we want to deal with that? Singleton. Let's give it larger names. Okay, great. Now what we'll do, instead of having this, we'll just okay, let's do this. Comp map com. Actually, let's place a bookmark here. And we'll rename this to map compound, or rather compound map. Assert dim. So it needs to map to another. Okay, in addition to the map, we want compound iter. And yeah, we need to put it in like this. Indeed, this is nice. We could also do it inline. Actually, no. We need to do it like this. We couldn't do it inline because doing it inline would not generalize the function properly. It wouldn't give us back the proper foralls. Compound map. Now we need like compound iter 2 in order to be able to actually no, wait, what am I doing? And this takes in oh yeah, perfect. I'm just wondering, I don't think we should be able to have something like singleton B. I mean, oh, it's possible. Yeah, now it's G and this pair type. Oh, okay. Okay, let's save this. I want to go back to the earlier version just to see whether we can have a pair and a singleton type in one of those other cases. Let's see. Switch. Check out commit. And now, as you can see, we have the row pair applied. We have these pair types back and applied. Oh, for fuck's sake. And if you go here, can we have something like row pair reduce local, and then row reduce pair oh, we cannot. Row row pair applied. Yeah, this is reduced TZ. It's trying to unpack a pair here, so the unification is failing. You know, even though we added the higher ranked types just for this, I actually like this version better than the one that we are doing in the redesign. So we're probably going to keep it as it is. Okay, we can tighten things up a bit. I understand how. Let me just do it. So let's see. We'll. For fuck's sake. We'll throw away all of this. Going to master. And it's super annoying how I cannot go to the master branch and how did I reset it last time? Reset current branch to tip. No, wait. Or is it something else? Like I did this just like an hour ago. Okay, let me pause here so you can figure this out. Fuck git. Okay, I have no idea how I managed to lose the head, but it's still present here. You can see, okay, here is head 3 commit save, and moving from, I guess, this to the other one. So let's do this. Okay. For fuck's sake. Okay, how the hell do I stop Git from doing this? Git checkout. Thank fucking God. Okay, now what the hell is going on? I guess we'll push it. No, why the hell would I want to create a pull request? Okay, I hate this version control software. It's not doing anything that I want. I really should be creating temporary branches instead of checking out. That's why this happened. Okay, so what the hell do I do here? Open all changes, compare head, undo commit. But I want it to go forward. Why cannot it push it? Save to. Okay, I want you to commit this. Okay, git push force. Fatal, you're not currently on a branch. Okay, why am I not on a branch? Git switch to branch. Okay, whatever. I was saying that we're going to keep the version that already exists because. Oh, no, wait. I was going to say that I know how to fix the issue with that thing. Okay. Okay, let's do git checkout. Now we are on the save. Now let's go back to the git push. What was it saying here? Git push head master. Okay, let's do. Head. Wait, what the hell is going on? Okay, let me pause here while I figure this out. I mean, yeah, I can just take this fucking file and switch to the branch and copy paste it instead of fucking around with git here, but I want to understand what the problem is. Okay, I got it. I just had to do this git push origin head master, and then it pushed it to the origin. I have no idea why we cannot push it to a local branch, but whatever. Okay, so we have this, and what I want to do is we're going to have a nominal pair and this is going to be what pair, maybe like this. Yeah, no, not bad. And okay, that still didn't fix it. It's just assuming that this A here is has a pair inside of it. I mean, okay, compound F singleton T. Forall FT. Okay, this is good. Now this should, yeah, now this finally gives a type error. Hallelujah. I mean, and also, do we still need this pair? Yeah, we don't. We know that this is a singleton now, so it cannot split it up into pairs. Yeah, that's perfect. Okay, so this is how we can do this in a type-directed manner. But you know, if you look at the function itself, it's not really that better in my view. Let me think. Compound, row up, local. Okay, the assert is like this. Now the story is like this. Let's and row map local. This is just a singleton. 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 This is now pair, and this is singleton, singleton. Singleton. Okay, what is this like? I guess because I was looking in the Git history. Okay, great. And so we have this like so now. And we're going to try compiling this. Let's just comment out everything past at this point, because there are a bunch of errors and want them showing up. Yeah, no problems. And okay, we're going to build the file. Let's see what the problem is. Only stack locate primitive types I8, I16, I32, I64 are allowed in CuPy arrays. What's the problem? This. Output sampling. Okay, output sampling, what's this? A tensor of tensors? I mean, local softmax and discrete sampling? Oh, I see. And this should be map reduced, not this. This should be taking in like 2 output arrays, I think. Okay, let's see. Output sampling. Yeah, this is tensor create M and output softmax. It's MN. And output, output sampling. Yeah, like this. And we need the output softmax. Wait, why aren't the dimensions matching up? Also, I didn't realize that we didn't test the new version of raw map reduce. Okay, let me put a bookmark here. Now, what the hell is this? I mean, let me get rid of this. We're going to go from top to bottom anyway. And let's do a search for this. And from is dim int a. Oh, because we passed as a pair. Okay, I see. I mean, I didn't have to do it like this, but yeah, since I didn't have to do it, let's just split them up. To reduce. Yeah, now this works. Even for me, type errors are hard to interpret. It's easier to actually look at the arguments directly, and then you understand what's really wrong. You really have to keep track of the flow of types as they go through the function. It's very hard to figure out anything just by reading an error. I mean, if the error is sufficiently complex. Okay, so now let's try finally building the file. And here we have the primitive spy. Oh yeah, this looks fine. Yeah. Let's also try the block let's also try printing out the masked softmax. (26, 33, 13, 26). I mean, yeah, this probably sums up to 100. I mean, to 1, 200%, which is 1. 11, 28, 67. No, 11, 2.8, 67, 18. Yeah, I mean, this looks like this is roughly 33. 11 plus 18, 29, 28. No, this is 2.8. For fuck's sake, let me just put it in. I'm just being NL here, but for fun, let's just try to sum it up directly. We'll set the language to F#, and then do list sum. And I'll press Alt Enter here, and the sum it sums up to 0.99999, which is close to 1. No problem, it's correct. Yeah, so I guess the higher ranked types work. We'll stick with this version. It doesn't really matter that much whether we keep this or whether we use what we had before. I like it either way. Let me just think about something. Row. Can we have for fuck's sake. Yeah, exactly what I was looking for. And could we have something like row reduce, row map applied? No, we cannot. Because this is reduce. And if this is reduced, then this should also be reduced. What I mean is, before it goes into the match statement, it only knows this is a type variable. But once it destructures this, it knows that the type variable is reduced to. It needs to be wrapped in a reduce. So this also needs to be wrapped in a reduce, but it's wrapped in a map, so it gives a type error. And this is a void case. It's an invalid case. In a dependently typed language, instead of just giving you a type error, you'd be able to write out the case explicitly and then say this is a void case, and then it would pass type checking. But in Spiral we don't have that, since it's not a dependently typed language. Maybe we could add something in match cases to make that happen, but it's not really a priority for me. Like, if you miss a batch case, you'll get a type error during partial evaluation, and that will be it. Unlike dependently typed languages, all that you see in the top-down segment is just a wrapper around the bottom-up segment. I haven't really intended Spiral to be, a quote real language. It's what you see in the bottom-up segment, what Spiral actually is, at least to me. That was the entire language in 2018, but it's just too difficult to program in the bottom-up segment, so I had to put in global type inference and so on. But the language that I do actually want to program is the bottom-up Spiral. I just want extra automation to make it easier to deal with. That's my design philosophy. I think I did a very good job designing it. Yeah, now we have proper higher ranked types here. It's spectacular. If I put in, yeah, this is taking in a T, but this has a forall B quote, and it's perfectly fine actually. Oh wait. Oh wait, oh shit. I actually have a huge problem with this feature that I didn't think about. And actually, no, maybe it's fine. Yeah, it's actually fine, because all the type variables will be, all the type variables that this store function takes in, for example, which are dim and which are dim, and I don't think we are using any other type variable. But for a minute there, what I was afraid of is that suppose we are passing this store function into another function, and then it has also a forall dim. Then that could get. I thought that it could overwrite the one in lexical scope here, but then I realized that this is impossible, because everything that's in lexical scope for this store function will be in its environment. That's how it's done during partial evaluation. So yeah, it's perfect. There's no issue at all. Lexical scoping is a very important feature of Spiral. Programming in this language, you'd take it for a given, but many languages don't have lexical scoping. And Spiral does, and it's absolutely great. It's amazing. I think lexical scoping is one of the greatest inventions of functional programming. It makes the language so much more expressive. And yeah, this is basically it. I think we're going to release the new version of the language. Higher ranked types work. Git checkout. Okay, enough. I don't know why I'm reading that. Regarding that issue, I even had to, go back through the video just to make sure that I did commit it, and I did. So I was really confused that I somehow lost the commit. I have no idea how that could have happened. Okay, now that's about it here. Let's go. Let me open the readme. In fact, we need to open the changelog as well. The readme I edit in Visual Studio Code. Yeah, and this is basically fine. Okay, let's release it. And no. First I need to First I need to update the readme. I'm going to pause here and come back when that has been done. Okay, we have it. We wanted to write a map function over higher kindeds, so we added it in. Check out the higher rank type section in the docs for more info. Unlike with GATTs, we didn't really need these, but it is better not to restrict ourselves when it comes to language design. Maybe now that we've met a minor need, it will lead to other more important uses being discovered for it. And here's the section. Spiral as of v2.13.0 has support for higher ranked types in the top-down segment. The foralls can be written as types anywhere, and types containing them can be stored in nominals and union types. Here is an example. And this is very similar to the identity example that we did before. I'm just showing that arbitrary types can be passed into the identity function here. And this is what comes out once you compile it in the F# backend. Previously, it would have been impossible to put a forall as a part of a variable's type. Now it can be done anywhere. In particular, what we wanted to do is write the following function. And this is the compound type, and this is the compound map. What having foralls in variables allows us to do is write a function that can map over higher kindeds, like the compound map above. We make good use of it in the ML library. Okay, that's a bit of a lie, but whatever. The special grave dollar operator has been added to the language to support its use. It blocks automatic type variable application. If you hover over the ID in the editor, you will see that it says forall TTT just as its type signature. Maybe I could write this a bit better. The same. Wait, do I need a quote here or not? Just a second. You know what? Let me just add its type signature. I'm just going to go with my gut here. If it weren't for the grave dollar operator, the variable would have had its foralls automatically applied and would not be passable as an argument into the given function due to it expecting a forall, but the identity having a concrete type. Much like existentials, foralls are a compile time feature only. The code using them cannot be generated by any of the backends, and they'll give an error upon dinning. They have to be inline and specialized away. And I hope this is clear enough. It's not really... The foralls aren't a complex subject to grasp, I think. So great. Now we can release the new version of Spiral. And I needed to do this before releasing it because the readme will get copied into this folder before being released as an extension. The reason for that is when you, for example, go into Spiral, you see the readme right here. This guy just keeps adding new users. I really am curious what he is doing. who knows? Maybe they'll get in touch with me at some point, or I'll if I manage to finish this video. Okay, I'll probably be right now. What's going on is that I have I'm just putting these clips into one huge video, and after I integrate the ML library with Leduc, I'm probably going to split them up into a bunch of clips. And after that is done, I'm going to, maybe just send an email to this guy to ask him what's going on. We might end up working on Leduc for a few more weeks, so who knows when that will happen. We started working on GADTs, and then we started working on high rank types, and then we're constantly redesigning the library, so it's taking a while. And I'm only programming a few hours a day due to having to go to the beach and play computer games. So who knows how long it will take us to integrate to complete the ML library and integrate it with the Leduc. After we are done with the Leduc, the no limit Holdem part will be a lot easier, that's for sure. Okay, so this is a minor version. Let's run this script. And now we'll have to wait. We do 13.0. Oh, not bad. Okay, I'm done with this clip. I'm going to take a short break. And we'll continue after the new version gets released on the VS Code Marketplace. We've done quite a lot of work today to get it to get it running and test it out. And it's very great that we have higher ranked types in the language now. I remember maybe a few weeks ago talking, after we finished work on GADTs, how higher rank types would be difficult and they're not really worth putting in. And we ended putting them in, and they're the last major language feature that Spiral will get, as far as I'm concerned. I don't think we'll be adding any more type level features. What else is there? Maybe effect handlers, but that will be too complicated, and we cannot really compile effects on GPUs. We definitely don't need those. We can just make up for them using monads anyway. So yeah, V2.13 should be the last major language feature. We were only really missing higher rank types, and now the language can be considered as complete as it can get. Effects, maybe lifetimes like Rust, dependent types, no, those will never go into the language as far as I'm concerned. Unless, I upload my mind and get 1,000 times more brain power than I have currently. I won't really feel like adding anything more. So yeah, from here on out, we're just going to focus on making the ML library, making the game. We'll fix whatever bugs we run into along the way, but otherwise, Spiral is done. And that's great. I didn't think it was really possible to just put in high rank type so easily into the language, but I was wrong. As soon as a need arose, they just went right in. I said I wouldn't put them in, and then I went to the beach and started thinking about how they could be put in, just to reassure myself that it would really be as hard as I thought it would be. And then I realized that it would be actually pretty easy to put them in. Okay, let's take a break. See you in a few moments.